and now we reach the more nitty-gritty part of our course on linear relationships. And you've heard me in the previous videos loosely define and mention this word gradient. Now, this is one of the more important concepts to get your head around in terms of understanding linear relationships, because often we're given formulas for things like this. I'll give you a formula in this video for calculating the gradient, and we'll look at an example. But the biggest thing to keep in your mind is that all linear relationships are about, the main thing they're about is how two variables interact and change with one another. So when we had an equation of, say, I don't know, y equals 4x, we're looking at how does y change with x here. And a big thing that tells us that is the gradient. The gradient tells us A, as we defined in the last video, to what extent y changes. So how many units does y change for every unit of x? Now, in the previous videos, maybe it changed half a unit for each time x changed 1 unit. Now, same as here, sometimes it changed -2 units for each unit of x. So the gradient, it both tells us how these two are changing, how one changes with the other, to what extent, and also whether this is a positive or a negative relationship. Is y increasing with x? Is y decreasing with x? So what we're going to look at here is an example where instead of just giving you the gradient, which we can read off in the equation, sort of like how I did here, I'm going to give you a slightly more abstract question. I'm giving you a graph here that passes through 2 points, and we want to find what the gradient is in the first place. And a way we can do this is, well, we define the gradient more or less in the previous videos, but I'm going to give you just a mathematical way to represent the gradient, and you should hopefully see through the intuition we've built in the previous couple of videos how we get to this, right? So our gradient, which in maths is given by the letter m for whatever reason. I don't know why they picked the letter m and not g, but we think of our gradient as m, and we think of this as the rise over the run, or the ratio of the rise to the run. Now, let's think of this in terms of an x and y graph. Well, if I think of how much something rises, I'm looking at a vertical component of my graph. So the rise here talks about my y, or my change in y. And the run, I can't give you as good of an analogy, but we run usually on horizontal, in a horizontal line, right? When you go for a run on the street, you're running on flat ground. You're running in a horizontal path. So we can define the run as changes in x. Now, for example, let's take this particular graph here, and I'll just move this down a tad bit. So we've defined the gradient as how much the y changes as a ratio to how much x changes. This is a mathematical definition, right? Now, I've given you 2 points here. I haven't given you an equation, but I have told you that at one point of the graph, at one point I should say, the line runs through the coordinate -1, -1. Sorry, I've miswritten that. We have -1, -1. and it goes up to 3, 1. So 3 in the x. I've got these the other way around again. Sorry, guys. I was really sloppy with the way I've written these. So I had my x's and y's the other way around. Obviously, the x comes first. It is 1 along the x-axis and 3 along the y. Okay. Sorry about that. Little technical error on my part. But we are, to reintroduce the definition we had before, we're just looking at how y changes with x. How much has y moved from one point to another compared to how much x has moved from one point to the other. So if I look at the vertical component here, so how far up have I gone? Well, I've gone from -1 all the way up to 3. So I can count how far that's gone. I have 1, 2, 3, 4 units in the y direction. And in the time I've gone up 4 units in the y, well, how far along have I gone in the x? And you'll see here that I've gone from -1 to +1. So that is 2 units. So we're just counting essentially how far up I've gone and how far across I've gone. I've found the rise, how far up, and the, whoa, sorry about that, and the run, how far across. And these correspond to my y and x axes on my graph. So pretty much here, I can just look off on my graph and I can say, all right, well, for every 2 units I've moved in the x direction, I've moved up 4 units. And the gradient is just a ratio of these two. So I can say m equals 4/2, which just simplifies to 2. Now, let's look at what I found and use the intuition and sense we built in the last couple of videos just to check this. So let's say we didn't do all the way from here to there. Whoops. Say we didn't go from all the way up to here, all the way up to there. But say we take this point, for example. Now, we have this as 0 on the x-axis and 1 on the y-axis. Now, it has gone, to get from here to up here, it's gone across 1 unit from 0 to 1 and 2 units from 1 down here to 3. So what our thing is telling us is that, well, y goes up by 2 for each time x goes up by 1. It's the same thing here. We go from -1 to 0, that's 1 unit in the x, and we've gone up 2 units in the y. So this number here, based on the definitions from our previous videos, that makes sense, right? Because all our gradient's telling us is for how much x changes with y. Here, when x goes up by 1, y goes up by 2. So we can actually write this as an equation as well, because y just equals 2 lots of x, because it goes up 2 units every time x goes up by 1. So something like this would be the actual equation of our line, of our linear relationship. Now, one more little point I'll mention, because we're going to keep talking about the gradient, but a very important thing to understand here is that the gradient of a line is constant. So it will always be 2 no matter where we go along the graph, if this is in fact a line. Because say we went from here, 1 unit across, well, the graph will hit 2 units up here to 5 on the y-axis. And say we go down here, I say go up by 1 on the x, and I go up by 2 on the y. And I can keep going. I mean, I haven't drawn this line all the way through, but we can see this little stepwise motion going because my y and x are going up in constant intervals. Y is constantly going up by 2. For each time, x goes up by 1. And our gradient tells us that. Now we'll look at some more explicit formulas here, but I'm hoping just this definition of our gradient as a ratio of our change in y to our change in x, I hope that gave you a pretty good confirmation of the things we talked about in the last couple of videos. Now, the same works for the negative case. We'll talk about that in the next video. And I'll give you some more kind of explicit formulas, which is the ones you'll find in your textbook. But I'm hoping this gives you a good understanding of what the gradient is actually telling us and how it informs us of the changes in y compared to the changes in x. I'll see you guys next time.